Hello innovators. Today we are going to give you a detailed introduction of Raspberry Pi. Raspberry Pi is a low-cost credit card-sized computer that plugs into a computer monitor or TV and uses a standard keyboard and mouse. It is a capable little device that enables people of all ages to explore computing and to learn how to program in languages like Scratch and Python. It is a microprocessor board. Let us first find out the learning outcome of this video. That is, in this video, you will learn about what is a microprocessor, how does a microprocessor work, applications and benefits of microprocessor, what is Raspberry Pi, hardware requirement for running Raspberry Pi, hardware description or components of Raspberry Pi, pin description of Raspberry Pi 3, how to install Raspbian in Raspberry Pi. Let's start by understanding what a microprocessor is. Do you know, almost everyone uses a computer these days, whether it's at home or at work. In fact, it is rare to run into someone that does not have access to a computer. We depend greatly on computers, yet few people really understand how computers work. How is a computer able to execute the commands that we input? The answer to that question is through the computer's microprocessor. Of course, knowing that doesn't provide much in the way of an explanation. We will give you an overview of what a microprocessor is, how it functions, and more about it. So what is a microprocessor? The microprocessor is the central unit of a computer system that performs arithmetic and logic operations, which generally include adding, subtracting, transferring numbers from one area to another, and comparing two numbers. It is often known simply as a processor, a central processing unit, or as a logic chip. It's essentially the engine or the brain of the computer that controls each and every function of the computer. It is a programmable, multi-purpose device that incorporates the functions of a CPU on a single IC. Let's find out a little about the history of microprocessors. Before the development of the microprocessor, there were a variety of early technologies for simulating logic functions in computing devices. Many of these early inventions were forced by wartime necessity during World War II. These early technologies were extremely expensive, slow, and prone to failure, and by today's standards, their capabilities were too primitive. Computing technologies based on vacuum tubes and transistors helped make IBM a giant in the large-scale computing industry, but were not realistic for business or home use due to their prohibitive cost and intensive maintenance schedules. Early integrated circuits appeared in calculators, of all things, in the early 1960s. Years before, Intel began work on the first recognizable microprocessor. Fairchild Semiconductors, founded in 1957, invented the first integrated circuit in 1959 that marked microprocessor history. In 1968, Gordon Moore, Robert Noyce, and Andrew Grove resigned from the Fairchild Semiconductors and started their own company, Integrated Electronics, which was Intel. In 1971, the first microprocessor, Intel 4004, was invented. A microprocessor is also known as a central processing unit in which numbers of peripherals are fabricated on a single chip. It has ALU, that stands for Arithmetic and Logic Unit, a control unit, registers, bus systems, and a clock to perform computational tasks. How does a microprocessor work? A microprocessor accepts binary data as input, processes that data, and then provides output based on the instructions stored in the memory. The data is processed using the microprocessor's ALU, arithmetic and logic unit, control unit, and a register array. The register array processes the data via a number of registers that act as temporary fast access memory locations. The flow of instructions and data through the system is managed by the control unit. Difference between microcontroller and microprocessor. Let's discuss this difference in terms of application first. Microprocessors are used in computers for a large number of tasks like gaming, document making, mathematical calculations, etc. It means that the processor is used where the task is not predefined. It depends on the user what task needs to be performed. Microcontrollers are used in devices designed to do particular tasks like digital cameras, washing machines, air conditioners, etc. Now let's discuss the difference in terms of internal structure. Microprocessor is just the brain or CPU. All the other components like the RAM, the ROM, memory, input-output ports, timer, serial interface are connected externally. So the size of the system is big. While in a microcontroller, it has all the components, the CPU, RAM, ROM, and other parts embedded on the IC. Hence, the size of the overall system is much smaller as compared to the microprocessors. Now let's discuss the difference in terms of processing power and memory. Microprocessors work at a much higher speed, having clock speed from 1 GHz to 4 GHz. And also, since it has to run an operating system, so the amount of RAM and ROM required is much higher. The RAM ranges between 512 MB to 32 GB and the ROM between 128 GB to 2 TB. While in microcontrollers, the operating speed is much less as compared to the processor, as it is designed for doing a specific task. Its clock speed ranges between 1 MHz to 300 MHz and also requires less amount of memory. The RAM ranges between 2 KB to 256 KB and the ROM between 32 KB to 2 MB. Applications and benefits of the microprocessor. Application. Microprocessors are used in handheld devices like smartphones, tablets, etc. They are used in general purpose computing like in desktops and laptops too. They are also used in high performance computing as in supercomputers, and they are used in appliances like smart home devices, games and cars. Let's discuss the benefits of microprocessor. Their cost is low due to use of IC technology. They are fast and they consume little power. Computers are a part of your daily life, and somewhere or the other, everyone is using computers. In the current scenario, you can't even think of what your life would be without a computer. So here we are introducing a small-sized computer named Raspberry Pi. It works similar to the normal computer. The only difference is in its size as compared to the normal computer CPU. We will share with you some interesting details about Raspberry Pi and how does it work. Let's begin by understanding what Raspberry Pi is. Raspberry Pi is a small-sized mini computer which can be fully used as a computer by attaching monitor, keyboard and a mouse. Its main advantage is its small size, unlike the normal computer's CPU. It is a single board computer. It is basically a microprocessor board which works on Linux-based operating systems. Any Linux-based operating system can be installed in Raspberry Pi, but the most popularly used OS, that is operating system, is Raspbian. It is capable of doing everything you would expect a desktop computer to do. from browsing the internet and playing high-definition video to making spreadsheets, word processing, and playing games. The Raspberry Pi has the ability to interact with the outside world and has been used in a wide array of digital maker projects, from music machines and parent detectors to weather stations and tweeting bird houses with infrared cameras. Let's see what are the basic hardware requirements for using Raspberry Pi. First, you need to have a monitor for display. Second, a keyboard for giving input. Third, a mouse for controlling the functions. HDMI cable or VGA cable or VGA to HDMI converter for connecting monitor to Raspberry Pi according to the configuration of your monitor. Hardware description or components of Raspberry Pi. It consists of 4 USB ports for connecting mouse, keyboard, USB webcam, and other USB devices with Raspberry Pi. It can also be used for connecting pen drives and other storage devices. It has a network port or Ethernet port. This port is used to connect Ethernet cable with Raspberry Pi for connecting it with the internet. So you can see that Raspberry is also accessible to the internet. Raspberry Pi 3B and 3i model also consists of Wi-Fi for connecting it with the internet and also Bluetooth for connecting it with the Bluetooth devices. There is a 3.5 mm jack for connecting it with audio and video devices. That is, we can also connect speakers with Raspberry Pi and play music. The company making Raspberry Pi has also made a camera strip for Raspberry Pi which can only be used with Raspberry Pi. And it has a CSI camera port for connecting that camera strip. There is an HDMI port and it is used for connecting monitors to Raspberry Pi. There is a micro USB port for powering the Raspberry Pi. The micro USB port is the same port as we have in an Android phone. So we can use our phone chargers to power the Raspberry Pi. We can also give power to Raspberry Pi with a laptop connecting the micro USB with the laptop. Raspberry Pi works on 5 volts and requires a maximum current of 2.5 amperes. So it is not advised to use the dash chargers with high current capacity as it could burn the inner circuit of the board. There is a separate PSI port of connecting external display devices like LCD and OLED. This is the slot for inserting a micro SD card which is used for installing operating systems and also as a storage device. A 16 GB micro SD card should be used if you are using Raspbian as an operating system. A maximum 32 GB SD card is supported in Raspberry Pi 3. Raspberry Pi board is mounted with an ARM Cortex processor which acts as a CPU for the system. This is the brain of the whole system. There are also general purpose input-output ports for connecting output devices like sensors, motors, etc. with Raspberry Pi for making any project or prototype. Pin description of Raspberry Pi 3. This board has a total number of 40 pins. These pins can be used to connect the external components and devices with the board. The first or top left pin is pin number 1 in a serial manner and the top right pin is pin number 2. The bottom right pin is pin number 40. This is how pin numbers are defined in a serial manner in Raspberry Pi. You can also understand it as the first column has all odd number pins and the second column has even number pins. There are 26 general purpose output pins from the GPIO 2 to GPIO 27, but the numbering of pins is in a random way and not in a serial manner. So it is difficult to learn it by heart. Hence, you can use the pin description image as a reference for using the GPIO pins. There are 2 into 3.3 volt power pins used for powering the components that have voltage requirements between 3 to 5 volt that you are connecting with the board. There are 2 5 volt pins used for powering the components that have a voltage requirement of 5 volt that you are connecting with the board. There are 8 ground pins on board for providing the ground or negative or 0 volt connection to the components you are connecting with the board. Ground pins are basically used as a negative power supply, as in a battery, for completing the power circuit for the flow of current. Pin number 3 and 5 in a serial manner, or GPIO 2 and 3 according to the GPIO pin numbering, are for 12C interface or connecting with 12C devices. Pin number 3 or GPIO 2 is also used for serial data SDA communication in 12C protocol. Pin number 5 or GPIO 3 is used as serial clock SCL in 12C protocol. Pin number 8 and 10 or GPIO 14 and 15 are also used as Universal Asynchronous Receiver Transmitter, which has a short form of UART pins, also called TX-RX pins. Pin number 19, 21, 23, 24 and 26 or GPIO 10, 9, 11, 8 and 7 respectively are used for SPI interface connecting to SPI devices. Pin number 27 and 28 in a serial manner are the reserved pins for board's internal functions and are not used for connecting any external device. Now we will see all the pins one by one in a serial manner and also according to their use. Pin number 1 is a 3.3 volt power supply pin. Pin number 2 is a 5 volt power supply pin. Pin number 3 is GPIO 2 pin. Pin number 4 is 5 volt supply pin. Pin number 5 is GPIO 3 pin. Pin number 6 is ground pin. Pin number 7 is GPIO 4 pin. Pin number 8 is TX/GPIO 14 pin. Pin number 9 is ground pin. Pin number 10 is RX/GPIO 15 pin. Pin number 11 is GPIO 17 pin. Pin number 12 is GPIO 18 pin. Pin number 13 is GPIO 27 pin. Pin number 14 is ground pin. Pin number 15 is GPIO 22nd pin. Pin number 16 is GPIO 23rd pin. Pin number 17 is 3.3 volt power supply pin. Pin number 18 is GPIO 24 pin. Pin number 19 is GPIO 10 pin. Pin number 20 is ground pin. Pin number 21 is GPIO 9 pin. Pin number 22 is GPIO 25 pin. Pin number 23 is GPIO 11 pin. Pin number 24 is GPIO 8 pin. Pin number 25 is ground pin. Pin number 26 is GPIO 7 pin. Pin number 27 is reserved pin. Pin number 28 is also reserved pin. Pin number 29 is GPIO 5 pin. Pin number 30 is ground pin. Pin number 31 is GPIO 6 pin. Pin number 32 is GPIO 12 pin. Pin number 33 is GPIO 13 pin. Pin number 34 is ground pin. Pin number 35 is GPIO 19 pin. Pin number 36 is GPIO 16 pin. Pin number 37 is GPIO 26 pin. Pin number 38 is GPIO 20 pin. Pin number 39 is ground pin. Pin number 40 is GPIO 21 pin. Now we will see how we can install Raspbian OS in Raspberry Pi. First, open any browser that you have here. We have Google Chrome. Type raspberrypi.org in the search bar. Open the first link showing raspberrypi.org. The Raspberry Pi website will open. Now click on Software. Scroll down and click on Download for Windows option. If you are using Ubuntu or Mac OS, choose the link to download accordingly. The imager file for Raspbian OS will be downloaded now. Now open the file in its location and install it in your personal computer. After installing, this dialog box will open. Now choose OS for your Raspberry Pi from this dialog box. Select the default OS for Raspberry Pi. Now before selecting storage, insert the SD card placed in the SD card reader in your PC. Now click on Choose Storage and select the SD card you inserted. Click on Write. It will ask to erase all your existing data in your SD card. Click on Yes. Now the OS will be installed or write in your SD card. Now again, it will ask to format SD card. Click on Cancel and remove the SD card from your PC. Insert the SD card in the SD card slot of your Raspberry Pi. Now connect your Raspberry Pi with other peripheral devices, monitor, keyboard, mouse, and give power to monitor and Raspberry Pi. And it will open the operating system on your monitor. Select the options showing according to you, and your Raspberry Pi is now ready to use. Now let's see the applications of Raspberry Pi. It can be connected with the monitor, keyboard, and mouse and can be fully used as a computer. It can be used to make home automation systems. You can control appliances like fan, TV, AC, etc. using this system. Both IoT-based and Bluetooth-based devices can be used as it comes with an inbuilt Bluetooth and Wi-Fi device. It can be used to make miniature camcorders or camera recorders. You can also make Xbox gaming console, gaming remote, using the Raspberry Pi. You can make an AI assistant similar to Google Assistant using the Raspberry Pi. Chatbots can also be made using this. Did you know? The first Raspberry Pi was introduced on 29 February 2012. It was made by Raspberry Pi Foundation. It is also used for night sky photography with good clarity. This is the image of Jupiter captured by the Raspberry camera. Some frequently asked questions related to Raspberry Pi are being shared with you along with their answers. Question 1. Can we use Raspberry to make the projects that can be made with Arduino? And the answer is yes. We can make Arduino-based projects with Raspberry Pi also, but it is not advised to make small-scale projects with Raspberry Pi as it is costly and used for higher-scale applications.